our borewell water is not at all nice. Mainly the groundwater comes from the Rishabha river, and it is unfit for drinking. In fact, it is if one really goes through that test report, it is horrifying. And then when we collect that borewell water, some kind of a layer is forming on top, some kind of soapy layer. I don't know what it is. Anyway, it is not really good for plants, and high residue of calcium and all is there. So dissolved salts, then E. coli and other human induced elements, and then soap, water, all kind of things mixed up in that river, and it goes into the entire underwater sources. In the borewell you get that only. So I thought we'll try some bioremediation, crude low cost one. So we made one tank now. This is a trial tank. On smaller scale I did some small trial. It looked nice. What I'm having idea is to fill up this with gravel and all, granite, stones and all that. Give little bit mud substrate for the roots to develop, and then introduce the hyper accumulators, and then such plants which are accumulating specific pollutants. For example, that Learsia indica absorbs a hyper accumulator of chromium, it seems. So it gets that color, and chromium contamination is quite high all over the urbanized areas. Then others are there like that, which suck up something or other in greater number, like cyanide, arsenic, lead, many of them. Each of them has few species which are good at absorbing that stuff. So aquatic things. So I thought we'll grow that here. Borewell water will come and fall down there, and then it will mingle with the roots of that plant, whatever we behave yourself. Whatever we plant here, roots will go through this, through all that. It will go through into the water. So water will be filled up here, whole tank. This much of substrate I thought we'll add, about this much, half this thing. And so once the roots fill up, roots will go out from there into the main water source, that collection area. And from here we'll put one outlet and one tap that will then go and feed our little that plants inside that shade net, like ferns and all, which need good quality, better quality water. So the theoretical aspect of this is first test the water to see what is in high contamination, then select the bioremediation plants and hyper accumulators of those pollutants, whatever is there in your water, plant them there, and allow the roots to come in over here, and they will suck up those whatever the toxic elements. At least some element will get absorbed by the plant roots, and also plant roots will be breathing in the water, these aquatic roots. So there also some microorganisms and all will naturally occur, and then I want to leave some fish and all here, so that fish breeding also can be done as extra in terms of black molly or something can be added if one wants, and then from here outlet is made. So water that comes in will mingle with the roots of those hyper accumulators, and then the breathing roots and all breathe and all. So in that finer hairs and all, many microorganisms are niches are created for them, and all kind of living activity happens, and the dead borewell water becomes alive. At least some nice bacteria and all can get introduced naturally, and that water, when we are feeding the plants, is better than putting direct borewell water. At least some biological activity has happened. That is what I am planning. So tank has been made. Next we have to waterproof it, then fill up that substrate there, and then add the selected plants. So that is the plan, and this is a low cost kind of thing. Anyway, we need water tanks, so this can be added as a extra feature, and whatever we grow here, that will be rich in that pollutant. For example, Earcia indica, if you grow, the roots will take up that chromium, and it will accumulate in the body parts of that grass. So we'll chop it, feed it to the worms or compost bin. So by the time it gets into much harmless form, having been processed through the systems of many living things. So that is one plan we are having over here.